Two blocks are there. They are kept on. There is a situation given like this. Let me help you with the diagrams. There's a block M1. There's a block M2. So what is telling? The force F that should be applied to the upper cube for which the lower one just lifts after the force is removed. So I'm pushing it with this force. Somewhere this is the natural length of the spring. This is going to help us a lot. This is the natural length of the spring. If you write L0, it's understood it's a natural. Spring is at natural length. Okay, what is the state of spring? Compressed or it is elongated? It is being compressed, no? So spring force, how much will act here? Kx1, the weight m1g. Then spring force here, kx2, oh sorry, kx1. Then weight m2g. Then the normal reaction. No, what is the state of block? They are at rest. Now, the moment if I remove this, now is it spring force greater than the weight m1g? Yes, it is. No, you can see that we will balance kx1 minus f minus m1g equals 0. So what is value of kx1 is equal to f plus m1g. So spring force is greater than the weight of the block m1g. So now what are the forces that are acting here? Spring force kx1 and the weight m1g. So what do you expect this block m1? It should accelerate, no? So it will have, it's going to accelerate. So so what actually we did, as long as I'm pressing this block M1 with a force F, what happen? M1 and M2, okay, there'll be a test and the spring is compressed here. The moment if I remove force, M2 will not lose contact. Because for M2 to lose contact, so look at the spring force, how even after just removing force, how spring force is acting downward, how the weight is acting downward. So when it will lose contact, somebody should pull it up, somebody should overcome it. Who is that somebody? The spring force only. So for the spring force on the block M2 to act vertically up, what should be the state of the spring? The spring what means should get elongated, no? So as kx1 is greater than m1g, so therefore the spring will get elongated. So when it comes to this position, so what happened? The spring, now the spring got elongated. So here the spring force now will act in this direction. So this will be m2g. This is the thing. So here this is a natural length. What we have took it. Now what is the state of this? So definitely what happened, what is the state of spring? Elongation. And what is this? Compression. And now what is the state of the block? Block is at rest, no? This will start accelerating from rest. It's asking, find the force F, minimum force F. Let me call this F, find the minimum value of force F that should be applied so that M2 loses contact. So when I apply that minimum force, when this F is minimum, so what do you expect the block M1 when M2 is about to lose contact? This will be again instantaneous rest. When you apply force greater than minimum, then the M2, M1, what happened? Will have some velocity. When the applied force is F minimum, then when M2 is about to lose contact, what is the state of M1? M1 will be at instantaneous rest. And now for M2 to lose contact, what is the condition? Kx2 greater than M2g. So let's get into the mathematics now. to lose contact, what is the requirement? Minimum, at least kx2 should be equal to m2g. Okay, what to do? I think I'll go for minimum anyway. How to bring that f? Because this f is what needed, no? So what to do with kx1? So let me take help of this state of the spring. So what is the energy stored in the spring? Kx1 square by 2. The energy stored in the spring here is kx1 square by 2. What happened this energy? A part of this energy is converted into increase in gravitational potential energy and also elastic potential energy. So equating, applying conservation of mechanical energy, kx1 square by 2 should be equal to kx2 square by 2 plus mg x1 plus x2. Now from where this equation I brought it? What all energy is stored in the spring here, a part of that energy is utilized to lift the block M1 to height x1 plus x2. Then the remaining will be retained in the spring itself. So this you bring on this side, k by 2, x1 square, x2 square. This is M1, no? M1g x1 plus x2. So 1 x1 minus x2 equal to finally M1g. So kx1 minus kx2 should be equal to 2m1g. Let's take help of this one. So what is kx2? Kx1 I'll write from here. So this is equation 1, 2 and 3. Put 1, 2 in 3. How much will get it? Kx1 will be f plus m1g. Kx2 is m2g equal to this is 2m1g. So what is that force? m1 plus m2 into g. This is our answer. If apply force less than this, if apply force more than this, is what you have to analyze. If apply force, if applies force just greater than or say greater than this one, what conditions will arise? If apply force greater than m1 plus m2g, then what when the m1 here will have velocity. If apply force less than m1 plus m2g, what happen before here only what happen the block m will come to rest and the kx2 will not be sufficient to lift the block m2. So shall I call this is like a minimum force to lift the block? If I apply force more than this, the block m2 will rise. But when m2 is rising up, when m2 is losing contact from the ground, the m1 will have some velocity. I think the word minimums, you have to be very careful. The minimum, maximum, no, because they will give a lot of information regarding the what we should assume the final situation. Why I should not say rest, because after this what will happen? M1G and weight and spring force both are acting. No? It will start moving down. So therefore I'll just use word instantaneous rest here. And what is the state of M2? This is at rest. And look at the normal contact. When it's about to lift, no normal contact will be 0. And here normal contact. And look at the normal contact acting on the block M2. Is it a constant or variable? It's a variable, no? Because as the block M1 starts rising up, spring force will decrease. So normal reaction between M2 and the ground will be varying. That one is not a constant. M2 will be variable. Okay, there are I think some, if you check book now, there are around 100 numericals are there on spring, not 1, 2. Different set of numericals are there. Almost maximum ideas I covered it. Now what are the few conclusions? At maximum compression or elongation, what is the state of the spring block system again? Horizontal vertical spring block at maximum elongation compression, the block will be at rest and at mean position it will have maximum velocity. When the two blocks kept on by a spring kept on horizontal surface and at maximum elongation compression open, they'll have common velocity. I think two different systems, so don't generalize it here. Two blocks kept on a horizontal surface and if I pull by a force, then at maximum elongation compression they must have common velocity. This is another thing. spring block system, here like vertical spring block or horizontal spring block system. At extreme points, the block will be at rest, acceleration will be maximum.